First half of lesson 12.5, we're learning about the law of cosines. The law of cosines can only be used if you're given all three sides of a triangle, or if you're given two sides and the angle in between. So if you're not given a picture, let's say you're just given the names of the sides and the names of the angle. If you're not given a picture, how do you know if it's the angle in between? Well, angle A has to be in between B and C. Side B, side C. Angle C has to be between A and B. And angle B has to be between A and C. The angle always has to be in between the two sides that have different letters. So if you're given all three sides, SSS, or two sides and the angle in between, SAS, there's going to be one solution always. You won't have the ambiguous case like you did with law of sines. Alright, so here are your three law of cosines. Law of cosines can be used for any triangle. It doesn't have to be a right triangle. If it is a right triangle, cosine of 90 degrees is 0. So if it is a right triangle, the last part of this formula will equal 0, and you'll have the Pythagorean theorem, which you know works for right triangles. So memorize these formulas. Again, it looks just like the Pythagorean theorem with one part subtracted on the end. Okay, for number 1, looks like we're given SAS. We're given side A, side C. The angle in between A and C has to be angle B. So we're going to use the second formula in the notes. We don't know side B. A is 14. C is 20. So it's A squared plus C squared minus 2. And then the sides we just used, but this time they're not squared. And we want to do cosine of 38. Okay, using a calculator, make sure you're in degree mode. I get that B squared is 154.7. I want to square root that, so I get B equals 12.4. The directions say round side lengths to the nearest tenth, and angle measures to the nearest degree. Alright, so we have all three sides now. We need two more angles. So how do we find the other two angles? So you could use the law of cosines and you'll get the right answer, or you might be tempted to switch to the law of sines. If you switch to the law of sines, you have to be careful because, as you saw in the last lesson, the law of sines has an ambiguous case where when you get sine of an angle equals some decimal, well, there's two possible angles that can satisfy that. So recalling from last lesson, sometimes the law of sines gets the biggest angle wrong, because sometimes there's another angle in quadrant 2 that works. So remember, law of sines sometimes gets the biggest angle wrong. So what you should do is, if you're going to switch to the law of sines, do not use it for the biggest angle. So right now, the letter that we have both of is B. We have angle B and side B. So we're definitely going to use that. Sine of 38 degrees over 12.4. And remember, 12.4 is a rounded value. So try to use the entire decimal that you should still have on your calculator. Alright, so again, don't use law of sines to find the biggest angle. We know the biggest angle has to be across from the longest side, and right now the longest side is C, which is 20. So we're going to use law of sines to find angle A instead. So again, sometimes the law of sines gets the biggest angle wrong, so you shouldn't use law of sines for the biggest angle. Okay, cross multiply and divide by 12.4. You get sine A equals 0.695. Doing inverse trig, you get that A equals 44 degrees. So we have angle A, side B, and now all we need is angle C, and we know that all the angles have to add up to 180 degrees. 44 plus 38 is 82, so angle C has to be 98 degrees. Okay, for number 2, they give us all three sides, so it doesn't matter what formula we use. However, on the last problem, I advised you not to use the law of sines for the biggest angle. So if the law of sines sometimes doesn't give you the correct largest angle, then I would suggest you use law of cosines to find the biggest angle. So right now we can see that the biggest angle is angle B because the biggest angle has to be across from the longest side. So I'm going to use the second formula again because I want to know angle B. So this is 6 squared equals 4 squared plus 3 squared minus 2, and then the numbers we just used but without the squares, times cosine of B. Alright, so we're trying to get cosine of B alone, so I'm going to simplify. 6 squared is 36. I'm going to move the 4 squared to the other side. Same thing with the 3 squared. Then I'm going to divide by the negative 2 times 4 times 3, which is negative 24. And so all this equals cosine B. So again, I simplified all the squares, and I moved everything to the left except for the cosine B. So simplifying, we get cosine B equals negative 11 over, or actually positive 11 over negative 24, which is negative 0.458, and repeating threes. Doing inverse trig, we get that angle B equals 117 degrees. Alright, so now you could switch to law of sines. Remember, law of sines sometimes gets the biggest angle wrong, but we already have the biggest angle, so we don't have to worry about that. Alright, so we definitely have to use angle B and side B. So sine 117. Remember, this is a rounded value, so be careful with that. Over 6 equals, and it doesn't matter what we find. Just don't use law of sines for the biggest angle. So I'll use sine A, which goes over side A, which is 4. Cross multiplying and then dividing by 6, you get that sine A equals 0.5925. Doing inverse trig, we get that angle A equals 36 degrees. And we know that all the angles have to add up to 180, so angle C equals... Okay, so what's interesting is if you're using exact values, you actually get 26 degrees, which is weird because all three of those do not add up to 180. They add up to 179, and that's due to a rounding error. All of these angles have like 0.3 or 0.4 attached to them. So if you imagine all of these with a 0.3 or a 0.4 after them, those would all round down, but 0.3 plus 0.3 plus 0.4 equals 1, so that's where the missing number went. Number 3 looks like another SAS problem. So we're given side B and side C, but not side A, so we're going to use the A squared formula. A squared equals B squared plus C squared minus 2BC times cosine of A. Using a calculator, we get that A squared is 4390. Taking the square root, A is 66.3 if we round to the nearest tenth. So now we have all three sides, and we need to find the other two angles. You can switch to the law of sines. The only pair that we have both of is A, sine of 103 over 66.3. Again, don't use law of sines to find the biggest angle, but we already have the biggest angle, so it doesn't matter. We know 103 is the biggest angle because a triangle cannot have more than one obtuse angle. So sine B goes over the length of side B, which is 31. Okay, take 31, multiply by sine 103, and divide by the 66.2589 number, and you get that sine B equals 0.4587. Doing inverse trig, we get that angle B equals 27 degrees. And all three angles have to add up to 180. 103 plus 27 is 130. So the last angle has to be 50 degrees. Alright, and now we're back to another side, side, side problem. Okay, I'm going to keep reminding you, law of sines is easier to use, but sometimes it's inaccurate when you're using it to find the biggest angle. So law of cosines is always honest about the biggest angle. So let's use law of cosines to find the biggest angle. Alright, B is the longest side. So we're going to use the B squared formula. 52 squared equals 31 squared plus 43 squared minus 2 times 31 times 43 cosine of B. Alright, so I'm going to move these to the other side, and I'm going to divide by the stuff in front of cosine B. So cosine B equals 0.03976, which means angle B equals 88 degrees. And now that we have the biggest angle, we can switch to the law of sines without worrying about the ambiguous case. Sine of 88 degrees. And again, I'm not going to use 88. I'm going to use the entire decimal that I have on my calculator. Sine of 88 over 52 equals sine of A over 31. Multiply 31 times sine 88 and divide by 52. You get sine A equals 0.5958 and angle A equals 37 degrees. And we just need angle C. 88 plus 37 is 125. So that means angle C has to be 55 degrees. Okay, and then one more SAS case. We have side B and side C. We don't have side A, but we have angle A, so we're going to use the A squared formula. A squared equals B squared plus C squared minus 2 times 12 times 17 cosine of 60 degrees. Alright, so doing that and then taking the square root, you get A equals 15.1. Switching to law of sines, sine of 60 degrees over 15.1 equals, and then don't use law of sines for the biggest angle, so let's do angle B because 12 is smaller than 17. Multiply 12 times sine 60 and divide by 15.1. Sine B equals 0.6867. So angle B equals 43 degrees. And what are we missing? We're missing angle C. 60 plus 43 is 103, so angle C has to be 77 degrees. And that is all for this lesson.